Alright, we have a bonus section for this part. This is what's referred to as the FOIL method, F-O-I-L. This is probably one of the most important sections of algebra that you're going to use just because of the nature of the problem that you're working with. However, FOIL stands for first, outside, inside, and last. So there's a pattern to working the problems for this section. So what you're going to do is, the easiest way to do this is to break it down into two levels. So if I look at my problem that I have in here, we're going to break this down pretty good here in what we're looking at. So our F stands for our first. First is here to here. So that's our first term. And then we're going to go to the O, which is outside. So we're going to go from here to here. So these are considered our outside terms. So first, outside. So when we get this, we're multiplying. So x times 2x. So there's our first. Now you don't have to do this part of it, but it just helps to look at the whole picture in just in chunks. So first, outside. Our outside is x times our 3y. So that's our first level. Our second level, I always put my arrows on the top just to break them up a little bit, make them a little bit different. So we have our inside, which is our I, inside 2y times 2x. So our inside is 2y times 2x. And then we have our last, which is our L, and that's our last numbers, 2y times 3y. So our last is 2y, 3y. So now once you have this broken down, now you're not going to do this for every problem. It would take you too long to do. So what you're going to do is you're going to make it look like this. So you're going to have your first and your outsides. You're going to put those together. Now again, we're looking at like terms, so we don't have like terms, so they cannot be combined together. So we put it as 2x squared. We have two x's, 2 times 1, and 3xy. So again, we have a 3. There's no like basis, so we don't add the powers. So we have 3xy for our second term. So that's our first level. Our second level comes from our inside and last. So our 2y, 2x gives us 4xy. So again, we don't have like basis, so we bring the numbers or the letters together. We multiply the numbers. So we have 4xy. Our last term gives us our last part, and that's 2y times 3y. That gives us our 6y squared. Again, like bases, add my powers, 1 plus 1 gives me 2. So when you set this up, you're going to set your like terms together. And they're going to be right on top of each other. There's no other 2x squares, there's no other 6y squares. So this comes in front, this comes in the back. This is the only part that you're going to be adding or subtracting, again, depending on the signs. Same signs I add, different signs I subtract, larger number carries the sign. So if there's nothing here to add, I'm just going to bring that down into my answer. I'm going to combine these two because they do have the same letters. So I have 4 plus 3 gives me 7. My x and y just come down to the answer. And again, I don't have anything here for 6y squared, so I'm just going to drop that down into the answer of 6y squared. So my complete answer comes out to be 2x squared plus 7xy plus 6y squared. So that's the first example of how we break this apart, tear the problem apart into first, outside, inside, and last. Again, this part you won't be doing. You're going to go from here directly to this part of the problem right here. So let's take a look at a problem just using that part of it. So again, first, outside, inside, last. First part up here, second part up here. So if you separate your arrows, this makes it a little bit easier to work with. So here's our problem. So 4y plus 2, 2y plus 3. So we're going to take our first and outside. So 4 times 2, y times y gives us y squared. Our 4y times our 3 gives us 12y. Our inside last, 2 times 2 gives us 4. With a y, there's your like terms that you line up. And you have 2 times 3, which gives you 6. So we do not have anything here to combine, so we're going to bring this down. We add these two together because we have the same signs. That gives us 16y, and our 6 just comes down. So our answer is 8y squared plus 16y plus 6. In our second example, we have our 5x plus 1, 3x minus 3. So now be careful of your signs here because we've changed our signs. And as you go deeper in algebra, you'll learn that with your signs of what you can find. So again, we have our first 5x times 3x gives us 15x squared. Our 5x times our negative 3 gives us a negative 15x. Again, the x just comes with because there's no x on the 3. We also have 1, now our inside and last, 1 times 3x gives us a positive 3x. I have a positive 1 times a negative 3 gives me a negative 3. Different signs, I get a negative. Again, lining up our like terms here. Now we're going to let the signs tell us what to do. Different signs we subtract, so 15 minus 3 gives us a 12. The x comes down. There's nothing that combines with the 15x squared and the negative 3. They go into your answer. So one of the ways that you can think about it is, in a way, it is like working with the distributive property. Twice. Because you have here and you have here. And that's how I'm going to break down the next problem that we go through here. So if we look at it as like the distributive property, what we have is our first part, which is our first outside. So we have really x, and then we're going to bracket it with this. So if we go back to the distributive property, we just distribute the x in. So we end up with 2x squared minus 4x. We have our second set, which is our inside last, 4 times 2x, and our 4 times a negative 4. So that gives us 8x minus 16. So again, you're kind of taking it and covering up this, and then covering up this, and you're working two different distributive property problems within the same problem. Now, once you get to here, now you start looking for your like terms. So we're going to put our like terms together in this. So we have a 2x squared. There's no other 2x squareds. We have a negative 4x and a positive 8x from those two problems. Those combine because they have the x in common. We have a negative 16 at the end. So now we bring our 2x squared down because there's nothing that combines with it. We have a negative 4x, positive 8x. So again, larger number carries a sign, different signs we subtract. X comes with it because it's our like term. And we have a negative 16 at the end. So our final answer for this is 2x squared plus 4x minus 16. So this is another way that you can look at the FOIL method as being a part of the distributive property twice. So let's take a look at one more problem. And we're just going to do the FOIL method completely. So this is how you would attack this problem. The other ways, we're just giving you ways to think about it. So we have 4x plus 3y, 2x plus 3y. They're multiplied, and that's how you decide whether you're using the FOIL method or not, is because you have this parentheses right next to this. That again shows multiplication. So our first is 4x times 2x gives us our 8x squared. Our outside is 4x times 3y. That gives us our 12xy. And again, letters are always put in alphabetical order, and we'll get to those a little bit later, more detailed. Our inside is 3y times 2x. So again, there's our like terms. So 6xy. And then we're going to take our last, which is 3y times 3y. That gives us 9y squared. We're going to combine the two. There's nothing here to combine with the 8x squared. We're going to combine these two because we have the same sign, so that gives us 18xy. And again, there's nothing here with the 9y squared. So this ends the notes for objectives 75 through 80. Please go back and view the videos if you need to help you out through this whole section. Refer back to your notes, ask questions in class, and hopefully this will go through fairly easily.